And let's continue with the last speaker before we come to the final fire chat panel. The next presentation will be given also by Tongwei, so it's actually a nice introduction into the executive panel. And the speaker will be Jason Chia, who's the Module Product Development Department head. And he will simply talk about module innovation from the world's largest cell manufacturer. The floor is yours.
Yes, thanks, Chairman, for the introduction. Let me share the screen. Okay, today I will give a presentation on module innovation from the world's largest cell manufacturer. My talk will be divided into 3 parts. Firstly, I will introduce R&D in Tongwei. Let's look at some numbers about Tongwei. Tongwei Company Limited is listed in Shanghai Stock Exchange with market value exceed 300 billion RMB in last July. It is fully owned by Tongwei Group. Tongwei is engaged mainly in 2 main industries. One is agriculture and the other is new energy, that's PV. Today, it has over 50,000 employees all over the world and more than 300 subsidiaries and branches. Tongwei is one of the top 500 enterprises in China. Some people on site may have misconception about Tongwei that it is the manufacturer powerhouse lacking of technology. But the fact is Tongwei pursues its leadership in quality, technology, cost efficiency, and production scale. Tongwei PV manufacturing sites are all located in China, including polysilicon, solar cells, and modules. Polysilicon manufacturing sites are in Sichuan, in the Mongolia and Yunnan province. Solar cell capacity is mainly located in Sichuan province. Module capacity now is located in Hefei, but this year we will have new capacity in Yancheng and Nantong in Jiangsu province. Our module exporter covers totally 60 countries in Europe, America, Asia, and Oceania. When go through the Tongwei's PV industry chain, we have the largest polysilicon capacity in the world. It reached 230,000 tons per year. Besides, our solar cell capacity right now is 70 gigawatt. Also ranked number 1 in solar cell shipment for 6 consecutive years. In Q2 of last year, we have reached the milestone of becoming the first company to ship accumulatively over 100 gigawatts of solar cells. Module level, we have achieved 14 gigawatts capacity and also 3.5 gigawatt in integrated fishery plus PV integration. Looking forward, the future production capacity of Tongwei, by the end of this year, we are going to have 350,000 tons of annual capacity for polysilicon, and we are reach somewhere between 800,000 and 1 million tons before the end of 2026. Our ingot and wafer capacity will be stay at 15 gigawatts, while the solar cell capacity will reach around 102 gigawatts by the end of this year, then to reach the range of 130 to 150 gigawatts by the end of 2026. When go to the module, for our module capacity, we have 14 gigawatts by the end of the last year. In this year, as I mentioned before, we will have new capacity and reach total capacity of 80 gigawatts. Actually, we have 3 national technology centers. Tongwei first became a national technology center in 2007, and then Tongwei Solar National Technology Center focusing on solar cell and modules, followed by Yongxiang National Technology Center on polysilicon materials. Now let's have a look at Tongwei PV R&D facilities. Our R&D is distributed in 4 locations. Most of them are in Chengdu, which is our company's headquarters. Technically, for HJT, Tongwei started the first HJT pipeline for M2 wafer size in Chengdu, and then the second HJT pipeline for G12 wafer size in Hefei. We started China's first gigawatt HJT pipeline production line in 2021, and then we built a new R&D lab on advanced modernization, primarily for HJT in Chengdu, also in 2021. For TNC, means Tongwei N-type cell, we set up a G12 wafer size R&D line in Meishan in 2020. We ramp up to 1 gigawatt on TNC production, in which half is G12 and the other half is M10 wafer size. For now, we have owned another 8 gigawatts TNC factory in Meishan. We also have dedicated pipeline for IBC development and well-equipped perovskite and HJT tandem developed lab. We also spent tens of millions RMB to build our solar cell characterization lab. Till now, we have 2 module R&D labs. One is in Hefei for shingling module, and the other one is in Chengdu for half-cut based module technology development. Meanwhile, Tongwei's 2 module reliability testing labs are both CNAS certified. Tongwei already published 1,484 patents, awarded 3 awards, and certified 5 platform qualifications by the end of 2022. Let's move to the second part, Tongwei's high efficiency cell and modules technology. The TNC, namely Tongwei N-type cell, the cell structure has an N-type substrate with boron doped emitter on the front side. The key point for high efficiency TNC is the silicon oxide and doped polysilicon stack on the backside, which caused excellent passivation and avoiding the direct contact between metal and bulk crystalline silicon, thus reducing the carrier recombination at the real surface. The method of polysilicon coating can be divided into 3 subgroups, which are LPCVD, PVD, and PCVD. And we use a PCVD method due to lower running cost, single site deposition, and a flexible process, such as multi-layers deposition. Let's take both eye view of our Meisan cell production site. There are 3 factories buildings. In the middle is the phase 1 factory, and on the left is 8 gigawatt TNC factory, and our R&D is also originated inside of phase 1 factory. As you see, this trend chart shows our G12 TNC R&D monthly efficiency improvement. The peak average efficiency exceeded 24.7% by the end of 2021, and now it is about reach above 24.8%. And Tongwei will focus on productive ramp up this year. And for M10 TNC, Tongwei was able to improve our R&D efficiency to more than 25.3% in last September. Our champion cell is at 25.6%, certified by the National Institute of Metrology of China last year. Talking to module innovation technology, here has a question: what kind of module technology can well matched with TNC cells? When go through the cell interconnection development history, it is found that we spent 11 years developed from 2 busbar to multi-busbar, which enabled a reduction of silver paste consumption and improvement of cell efficiency and module power. Last year, we were glad to find that SMBB, namely super multi-busbar, is mature enough to mass production, not only on equipment alignment, product yield, but also on module reliability. SMBB can further decrease silver paste consumption, which is especially deserved for TNC cell because of double-side silver paste equivalently. SMBB technology have at least 2 advantages. One is decreasing power loss when microcrack is happening, and the other is shorten current transmission distance to reduce inner resistance loss and thermal generation. Generally, there are 3 approaches for SMBB technology: soldering, adhesive, and smart wire. Due to well compatible with conventional multi-busbar technology, many on soldering machine capability, soldering approach is easier to realize multi-gigawatt mass production. High efficiency TNC solar cell combined with SMBB module technology means higher power output for TNC module. For G12 and M10 bifacial module, the high beam is about 695 and 580 watt, which is about 30 watts higher than the relative PERC module. Tongwei SMBB module have already passed TUV certification and double IEC reliability test. Due to better efficiency, temperature coefficient, no irradiance performance, and yearly degradation, TNC module can generate 4.2% more power than PERC module during 30 years outdoor operation. When moving to HJT, some of the key obstacles to keep HJT from real high volume production are cost and product differentiation. We put our effort to improve HJT's cell efficiency gap to PERC and TOPCon and to reduce cell conversion cost. We are trying to adopt half-cut ingot wafer. By doing that, we can eliminate cell level laser swiping for half-cut module. That's improving the CTM and wafer mechanical density. We will implement the nano crystalline silicon on both N and P sites to improve the current density. Metallization cost reduction, either silver copper paste or copper plating are investigated. Here you can see we have run batches of wafers as thin as 90 micrometers, and we have demonstrated negligible efficiency loss compared to the 130 micrometers thick wafers with good level of module mechanical loading performance. By applying nano crystalline technology and metallization optimization on cell level, soldering process and encapsulation material optimization on module level, G12 size HJT bifacial module power have been improved by 25 watts within 6 months. Now we can get HJT module power as high as 720 watts with module efficiency of 23.2%. Let's move to the last part and get conclusions. Tongwei has further strengthened its PV R&D in the last couple of years with one of the best R&D facilities and teams in the industry. Tongwei developed a PCVD-based TNC technology and have 8 gigawatts mass production by the end of last year. And Tongwei developed SMBB module technology, and we have tens of gigawatts in this year. Our latest HJT development enabled us to produce 720 watts module with further efficiency improvement and cost reduction technology in pipeline. Our R&D capabilities will be one of the enablers for Tongwei to become one of the best integrated PV manufacturers. And that's all. Thank you for your time.
Thanks, Jason. I think that was amazing, but I think we stop here, and the questions I will ask Guoqiang so that we save a little bit on time. Thanks a lot. That was wonderful.